All right, so today we're going to do 1.6, 1.4, and 1.5. That's kind of the order that I'm going to do them um, in getting all of them together in one lesson, just because they all relate together very easily. And so we're going to start it off with the unit circle. Now, if you want to, you can memorize this whole entire circle. I never memorize the unit circle. There's actually a hand trick, and I have left a video for you to watch on um, Canvas to see how that hand trick works. And it shows you about quadrant one, which is this quadrant over here. And then it tells using all students take calculus. Okay. And so this is saying that all the trig functions are positive in quadrant one. Sine is positive in quadrant two, and it relates to sine, cosine, and tangent. Okay. And then, of course, the reciprocal identities fall in place. So if sine is positive in quadrant two, then cosecant is also positive in quadrant two. Um, Tangent and cosine are negative, cotangent and secant are negative. All right. Then we have tangent is positive in quadrant three, which obviously means cotangent is also positive in quadrant three. And then cosine is positive in quadrant four, which means the others are not. Okay. Except for secant. Secant is positive. All right. It may be kind of hard to see this, but some of these here, I'll show you. Okay. So this ordered pair right here is square root of 3 over 2, comma 1/2. All right. Um, and so, like I said, when you're reading this ordered pair, you're reading it as cosine and then sine. Okay. Each one of these is always cosine, then sine. So cosine is your first value. So if I want the cosine of 30 degrees, then it would be square root of 3 over 2 is my answer. And then pi over 30 degrees is pi over 6. Everything that's on this unit circle, you will need to know. All right. But again, you don't have to memorize it. You can learn that hand trick with quadrant one, and it is using, well, depending on how you put it, your thumb is what's representing the 0, and then your fingers fall into place. Okay, so and then your pinky finger is representing the 90. So that's the way it goes. Your thumb is the 0 and your pinky finger is the 90. You can use the right or the left hand. I don't know which hand they use on the video. I normally use I think I use my right hand. So anyhow, but this is your thumb and that's your pinky. All right. And it again, it's important to understand that it's cosine then sine. Okay. When you're looking at your fingers, the top fingers are your cosine, the bottom fingers are your sine. So it goes in the same aspect as the ordered pair. We're going to get to become familiar with this when we start going through problems. And again, that's what part of 1.6, 1.4 is, and also part of 1.5. All right. Now, the other thing, keep in mind that when you can also convert your degrees to radians by using the pi over 180 or the 180 over pi that we discussed back in the first sections. All right. And so all this information can be obtained without having to memorize the whole entire thing. And I have a link to that where I got that unit circle from. All right, so when we're finding angles, we're going to be, when we're doing our trig, we're going to have to base it off of our x-axis. So it's very important to know how to find the reference angle based off of which quadrant you're in. And so in this case, these here explain how to get your reference angles. And again, it's all based off of the x-axis. So if you notice for quadrant one, it's obviously whatever angle you get. Reference angles are anywhere from 0 degrees to 90 degrees. Okay, or 0 to pi over 2 in radians. But if you notice, so quadrant 1, that's the angle, whatever it is. Quadrant 2, notice that it says alpha. This is your reference angle, this alpha right here. That is 180 minus pi. Here's your 180 degrees. So it's 180 minus pi, or it's 180 minus theta, or it's pi minus theta. Okay, if your theta is in radians. All right, looking at quadrant 3, again, basing it off of the x-axis, we're going this route. So in this case, if here's your alpha, so you've got the angle minus 180 because your angle is bigger. The angle has to go first. But again, it's always going back to that x-axis. If I'm doing radians, then I would say alpha equals your theta in radians minus pi. All right, and for quadrant 4, again, coming off of the x-axis, so here's my alpha. So that would be alpha equals 2 pi minus my theta in radians. So it's always based off of the x-axis. Reference angles are not based off of the y-axis. And we'll be using reference angles too, because I want to get it to quadrant 1 so that I can use that hand trick, and then I can use, just have to remember those items right there. We have reciprocal identities. This is cosecant, secant, cotangent, sine, cosine, and tangent. All right. So most of the equivalent forms over on this side, we will most likely not necessarily use those, but the reciprocal identities, we will be using those quite a bit. All right. We also have other identities. Sine is your y over r, which is your opposite over hypotenuse. Some of you may have heard of SOHCAHTOA. This is where SOHCAHTOA comes from. This is for your right triangle trig. So this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. All right, so that's where SOHCAHTOA comes into play, and that's where we get this information here. Now, where are they getting the x, y, and r? If you look at a graph, okay, and you're doing right triangle trig, okay, this is your x, this is your y, and this is your r. So your triangle, your 90 degrees is not on the axes, it's off of the axes. So that's where they're doing the x, y, and r, but it follows in the same suit. So if our angle measures right here, then sine is opposite. Well, opposite is y over hypotenuse, which is r. And so that's where all this comes into play. And then cosine, secant, cosecant, tangent, and cotangent all fall in the same place. So that's where that's coming from. Okay. Few more things I want to tell you about here. Is that tangent of theta is also equal to sine of theta over cosine of theta. Okay. Another one is cotangent of theta is equal to cosine of theta over sine of theta. The way I remember cotangent is cosine on top, is start with co. And you can print this form off of Canvas. I've got this all set, ready for you to go. And I think I've got the version that's not completed, but you can go ahead and complete it. All right. And all right. And then fundamental identity we'll be using quite a bit is sine squared plus cosine squared equals 1. All this information you need to get to know. That's why I don't like memorizing the unit circle, is because there's a lot to remember to understand the basis of trigonometry. And so all this is to help us to understand that basis of trigonometry. All right. Okay, so let's get into some problems and learn how to use this. That fundamental identity, sine squared plus cosine squared equals 1, is similar to your Pythagorean identity. Okay, Pythagorean theorem. And so, all right, so we're going to work on sketching the angle again, just like what we did in 1, 1 and 1, 2. And we're going to find all 6 trig functions for that angle. Okay. All right. May not have room for both of those, but we'll try. All right, so we're going to start with 5 pi over 3. So I've got my 0 because this is radians. Okay, so 0, this over here is 3 pi over 3. Then I'm going to keep going around. All right, and keep in mind I'm going this way. So 3 pi over 3. So now I'm coming around. This is going to give me now 6 pi over 3. So 5 pi over 3 is going to be about right here because I'm cutting this in thirds. So I'm going to come around and I'm going to label this as 5 pi over 3. All right, now I want to find all 6 trig functions. So I want the sine of 5 pi over 3, and we'll go on from there. Well, like I said, what I use reference angles. So because I'm in quadrant 4, I'm going to come off of the x-axis, and let me change colors. This is my reference angle. My purple is my reference angle. So that tells me I'm going to take 6 pi over 3 minus 5 pi over 3. Because again, I'm taking 2 pi minus 5 pi over 3, but I need that common denominator. So I think of it as 6 pi over 3. So that's going to give me a reference angle of pi over 3. And I actually use my left hand, y'all. Okay. All right. So my reference angle is pi over 3. Okay. So I'm going to do the sine of pi over 3, which is going to be square root of 3 over 2. And I got that from the unit circle or from my hand trick, just so you know where I got it from. I actually did it on my hand trick. And so anyhow, so that helps very, very well, because then you don't have to memorize anything and you've got your hand to help you out when working through the problems. All right, but 5 pi over 3, keep in mind, is in quadrant 4. So this is all students take calculus. So this is telling me that cosine is positive in quadrant 4, which means sine is negative. So sine of 5 pi over 3 is going to be negative square root of 3 over 2. Okay, now I want to do the cosine of 5 pi over 3. Well, that's going to give me 1/2. Again, I got that from the unit circle or from the hand trick. And cosine is positive in quadrant 4, so I'd leave it as positive 1/2. Now I've got tangent of 5 pi over 3. Your hand only does sine and cosine, but you can get tangent from doing sine over cosine. And it's all lined up if you do it in this kind of chart that I'm setting up here. And so if I do negative square root of 3 over 2 divided by 1/2, the 2's are going to cross off, and that's just going to leave me with negative square root of 3. So that's how I get tangent on that. I normally just do sine over cosine. And you don't need to show me the negative square root of 3 over 2 divided by 1/2. You just can do it in your head if you want to get negative square root of 3. All right, so now we're going to do the other 3 trig functions. So I've got cosecant of 5 pi over 3. And then I've got, that's an S. Then I've got secant of 5 pi over 3. And then I've got cotangent of 5 pi over 3. For all of these, I use my reciprocal identities. I take what I have and then I flip it over. So sine was negative square root of 3 over 2. So that's going to be negative 2 over square root of 3. And then rationalize. So I multiply top and bottom by the square root of 3. So this will give me negative 2 square root of 3 over 3. Then I do the same thing for secant, flip it over. So that's giving me 2 over 1, which is actually just 2. And then your signs are also already taken care of. So you don't have to worry about, oh my gosh, what sign do I use? You've taken care of it on sine, cosine, and tangent. It'll be taken care of on the other 3. All right, cotangent. Again, we're going to flip negative square root of 3 over. So that's going to give me negative 1 over the square root of 3. But I need to rationalize. So that's square root of 3, square root of 3. So this is going to give me negative square root of 3 over 3. And so that's how I get all 6 trig functions. Okay. All right. Let me, yeah, no, I don't have room there. I really want to do that negative 135 degrees. So let's go ahead and do the negative 135 degrees down here. I think I've got enough room, because the next ones won't take up much. So because I'm doing negative, here's 0 degrees. I'm going this way. Here's negative 180 degrees. So in that case, negative 135 is going to be about right here. Okay, and just get it in the approximate location. So here's negative 135 degrees. All right, my reference angle, you got to be careful on this because you're doing negative. Okay, my reference angle is going to be 180 degrees minus 135 degrees. And you're like, but wait a minute, that's quadrant 2. It is quadrant 2, but because we got negative, we got to use positive 180 to subtract it back because this is the reference angle that we're looking for. So we're actually going to negative 180 degrees. We're trying to find out what value, but we want it as a positive angle measure. So this gives me a reference angle of 45 degrees. So now I can go find my 6 trig functions. So I got the sine of 45 degrees, cosine 45 degrees, and tangent 45 degrees. All right, so sine of 45 degrees is going to be square root of 2 over 2. And we are in quadrant 3, so that means it's going to be negative because of all students take. The only one that's positive here is tangent calculus. Okay. All right. Cosine is going to be square root of 2 over 2 also. Again, either through the unit circle or the hand trick, but it's also going to be negative because of all students take calculus. And so tangent is sine over cosine. Well, they're both the same, so that's going to end up being a positive 1. So now I go find my reciprocal identities. So I got the cosecant of 45 degrees. I got the secant of 45 degrees. And I got cotangent of 45 degrees. All right, so if we flip over square root of 2 over 2, we're going to have negative 2 over the square root of 2. And if I rationalize, that's going to leave me with negative 2 square root of 2 over 2. So the 2's are going to cross off, which leaves me with negative square root of 2. Okay, and I did it up above because I'm running out of room. So that will actually be for cosecant and for secant. Both of those are negative square root of 2's. And cotangent is going to be the reciprocal of 1, which is actually just 1. Okay, so be careful when you're doing negatives, all right? Keep in mind your reference angles are always positive. Always positive. If you need to take a break at any point in time during this video, this would be a good time to take that break just to kind of process what we've done because we've done a bunch of stuff, but we've still got a bunch more to go. All right, so let's continue. We want to sketch the angle and evaluate the following without a calculator. Okay, so we start with the cosine of pi. We want to sketch pi. So here I've got 0. Here I've got pi. So that's my initial side. This is my terminal side. So I'm going from here to there. Okay, so that's how I would sketch pi. Now, I want to find the cosine of pi. Well, like I said, I like to use my hand because I don't want to memorize that whole entire unit circle. That's just a lot of information. And so here, I know that the cosine of 0, and I'm going to write out what I'm thinking. I know that the cosine of 0 is equal to 1. All right? Because pi is the opposite direction of 0. 0 goes to the right, pi goes to the left. Because it's the opposite direction of 0, then that means that it's going to be -1. So that's how I figured out the cosine of pi. Because we didn't work much with quadrantal angles up above, I wanted to start working on those and showing you how to do it. Okay, so cosine of 0 is 1, but I'm going the opposite direction. So that means it's got to be opposite of 1, which is -1. All right. And they didn't ask for all 6 of them, just for that one. So you don't have to give all 6 unless all 6 are asked. All right, secant. Okay, so here's my 0. Here's my 2 pi over 2. I come back. I've got 4 pi over 2. Well, 3 pi over 2 is actually a quadrantal angle. So here's my 3 pi over 2. And you need to have this little marking here with the angle measure to ensure that you're telling me which way the angle's going, whether it's a positive angle or a negative angle. All right, so 3 pi over 2. So again, I'm going to show you how I think this out. Secant is the reciprocal of cosine. So I want to deal with the cosine of pi over 2. I want to get this into that quadrant 1 or on the positive x or the positive y axis. So the cosine of pi over 2 is 0. Okay, again, either using the unit circle or the hand trick, whichever works best for you. The secant of pi over 2, well, actually, let me think this out a different way. Okay, so that tells me that the cosine of 3 pi over 2 is the opposite of that. Well, it's still 0 because the opposite of 0 is 0. Okay, so cosine of 3 pi over 2 is 0. Now I can do the secant of 3 pi over 2. That means I'm going to flip the 0. So that's going to leave me with 1 over 0, which is actually undefined. Because we can't divide by 0, it's undefined. If we had 0 over a number other than 0, then the answer is 0. Okay? And there are a few ways for you to think this out. This is just the way that I'm processing it through my brain. So I wanted to see how I'm thinking it through when I go through and work each one of these. All right, cosecant negative pi over 4. So again, I'm going to graph this. Here I've got 0. I'm going this way with it because it's negative. So this is negative 4 pi over 4. So negative pi over 4 is going to be sitting right here. And my angle's going this way. That's not an arrow, by the way. That's the arrow. Okay, so here's negative pi over 4. All right, so it's a negative, so I need to do my reference angle. My reference angle is going to be positive pi over 4. If it gives it to you as a negative in quadrant 4, then all you just have to do is take the negative off and you've got your reference angle. All right, the time that you have to use the 2 pi minus is when they give it to you not as a negative, or they give it to you as more than one rotation. All right, so our reference angle is pi over 4 here. So I'm going to start cosecant. I'm going to start with the sine. So I know the sine of pi over 4 is equal to 1. Oh, square root of 2 over 2. I'm thinking of a different trig function. Square root of 2 over 2. Okay. So now I need to get it into the quadrant that it's asking for. So now I do the sine of negative pi over 4 is going to be, since it's in quadrant 4, all students take calculus. So this tells me cosine's positive. So sine is going to be negative square root of 2 over 2 in quadrant 4. Okay. All right. Now I can change it to cosecant of negative pi over 4, which means I'm going to take the reciprocal. So I have negative 2 over the square root of 2. And then I rationalize square root of 2, square root of 2. So this is going to give me negative 2 square root of 2 all over 2. Or in other words, negative square root of 2. And as you get better with these, you won't have to show out all this rationalizing here. You'll just know that the reciprocal of square root of 2 over 2 is just going to be square root of 2. All right, cotangent of 420 degrees. Okay, so here I've got my 0 degrees going around to the positive way. This is 180 degrees. Then we have 360 degrees, and we didn't hit it with one rotation. So I normally, if it's not hit within one rotation, if I see if it's bigger than 360 or smaller than negative 360, again, 2 pi, negative 2 pi, then what I like to do, I like to go find that coterminal angle first. So I'm going to do 420 minus 360, which ends up giving us a 60-degree angle. This also tells us, because when we subtracted, we ended up with an angle in quadrant 1, this also tells us that 420 degrees is going to end in quadrant 1, because coterminal angles have the same ending. So when I draw my angle, I'm going to go around one rotation, and then I'm going to come back, and that's my 420 degrees. All right. Now, we're doing cotangent. What I like to do, I like to start with sine. So the sine of 60 degrees is going to be square root of 3 over 2. Again, either the unit circle or the hand, whatever works best. Cosine of 60 degrees is equal to positive 1/2. Okay. Now I want to get those into the 420 degrees. Well, this is also the sine of 420 degrees. Being that it's coterminal with 60, then those are exactly the same. So that's going to be square root of 3 over 2. And then cosine of 420 degrees is also positive 1/2. Now, to do the cotangent of 420 degrees, I'm going to use my cosine of 420 degrees over my sine of 420 degrees. So this is going to give me 1/2 over the square root of 3 over 2. So the 2's cross off. I end up with 1 over the square root of 3, and then I rationalize it. So that's going to give me square root of 3 over 3, because I'm multiplying top and bottom by the square root of 3. And so this ends up being my answer. You could have also done your tangent if you want to go straight for tangent and then do it as a reciprocal identity. You can also do that. It does not matter which. All right, so next we got 45 degrees. That one shouldn't be too bad because it's quadrant 1. So here I've got my 45-degree angle. Again, I started with 0 degrees. This is 180 degrees if you want to label it. Okay. And we want the very basic. So we want the sine of 45 degrees. That's an easy read off of your chart, off of your unit circle, or an easy read off your hand. So that's going to be square root of 2 over 2. And it's positive because we're in quadrant 1, and all of them are positive in quadrant 1. So this ends up being your answer. All right. Next, we have 5 pi over 3. So I'm going to start with 0. This is radians. This is going to be my 3 pi over 3. Then I have 6 pi over 3. So my 5 pi over 3 is landing right here. I have 5 pi over 3. Don't worry about if you've done it before or not. Keep practicing every time of getting those angles. So this is 5 pi over 3 here. We need our reference angle because it's not in quadrant 1. So we're going to take 6 pi over 3 because we're coming off of the x-axis, that using the bigger one. So 6 pi over 3 minus 5 pi over 3. That's going to give me a reference angle of pi over 3. So thinking it through, I want to do the sine of pi over 3, which ends up giving us square root of 3 over 2. But now I need to get it in the right quadrant. So the sine of 5 pi over 3 is going to be negative square root of 3 over 2, because we're in quadrant 4. Again, all students take calculus. So cosine's the only one that's positive, which means sine is negative. And so the sine of 5 pi over 3 is negative square root of 3 over 2. All right, tangent negative 13 pi over 6. So here I've got 0. I'm going this way because I'm going negative. So I've got negative 6 pi over 6. And keep going around. So that's going to give me negative 12 pi over 6. So that tells me it's more than one rotation. So here I'm going to have negative 13 pi over 6 plus 12 pi over 6 tells me that it's negative pi over 6. So it's going to land right in here. But again, when I go around, I'm going to do one full rotation till I hit it. So this is my negative 13 pi over 6. My reference angle, good news, once I got this, told me my reference angle is positive pi over 6. I don't want to use 13 pi over 6 as my reference angle because that's bigger than one rotation. All right, so I'm going to start with my sine of pi over 6. So sine of pi over 6 is going to be 1/2. Okay, I'm also going to start with the cosine of pi over 6, which ends up being square root of 3 over 2. So this is my brain processing through. All right, now I want to do the sine of negative 13 pi over 6. I can jump straight to that because I've drawn it out and it shows me what quadrant it's in. So I've got all students take calculus. Okay, so quadrant 4 we're going to be in, which tells me that sine is going to be negative. So that's negative 1/2. Okay, cosine of negative 13 pi over 6. We're in quadrant 4, cosine is positive, so that's going to stay square root of 3 over 2. And notice I kept it as the basis of sine and cosine before worrying about the tangent, okay? Now that I've got my angle measure all set, now I can do my tangent of negative 13 pi over 6. Okay, so in that case, that's going to be sine over cosine, so negative 1/2 divided by square root of 3 over 2. So these will cross off. And that's going to leave me with -1 over the square root of 3. Again, you will need to rationalize. So multiplying by the square root of 3 on the top and the bottom. So this is going to give us negative square root of 3 over 3 as our answer. Now, most of the denominators that you're going to recognize for us to get exact answers on are going to be 4, 3, and 6. Okay. Not necessarily in that order, but 4, 3, and 6, 2, you're also going to see. And so keep those in mind. Well, my math lab is going to give you 7 pi over 8. I'm not going to give this to you. Okay. Not at least until after we get through learning how to remember these. All right. So my math lab's going to give you something like the cotangent of 7 pi over 8. So the way that you're gonna have to use a calculator on this one, unfortunately. Okay. Um, I would love to delete these off, but you need it for future reference. And so anyhow, so they're on here. All right. Your calculator does sine, cosine, and tangent. So what I would do this, first of all, you got to change your calculator from degrees to radians. Okay. Since this is in radians, you have to change it into radians. So there is this DRG button, and that is for degrees, radians, and gradients. I don't know if that's how you spell it, but we're not going to use that one anyway. Okay, so degrees, radians, and gradients. All right, so you need to click on that button, make sure it turns into radians. If your problem's in degrees, then you leave it in degrees. All right. Next, because your calculator only does sine, cosine, and tangent, you can either do this as cosine over sine, or you can do this as 1 over tangent. I like to use the less amount of trig functions as possible when working on the calculator, that is. Okay, so what I'm going to do, I'm going to do 1 over the tangent and then parenthesis. Might pop up a parenthesis. I hadn't used a calculator for trig in a long time. Yeah, it does pop up a parenthesis. And then do 7 pi divided by 8, close parenthesis. Okay, so 7 pi divided by 8, close the parenthesis, equals, okay, and it will give you the answer. So use your reciprocal identities when working there. That way you're only dealing with one trig function. So I've got 2.4142 for that decimal. And like I said, the ones that I'm going to want the exact value. And so you don't have to worry about this part being on your test. It won't be there. It will have a denominator. It won't have a denominator, or it'll have a denominator of 2, 3, 4, or 6. So that's it for, oh, maybe not, maybe not. Nope, I'm jumping the gun. Okay. This is another time to take a good break if you want to. Like I said, this is technically 3 lessons into one, but they really relate together. And so, if you want to take a break, go ahead and take a break. All right. So we're going to go and work on, right triangle trig. Okay. And, the key on right triangle trig is to draw the picture. Okay. Anytime you need to draw your picture, because your picture is going to help you out tremendously. The terminal side of an angle in standard position, we talked about standard position when we first were starting the trig class, goes through the point 0.85. Okay. So this tells me that it is in quadrant 1 because X is positive and Y is positive. So here I'm going to have, or 815. Okay. So I'm going to have this point here being my 815. Now, I don't normally label that point, just FYI. I normally label it on the sides. My 8 is my X, my 15 is my Y. And my right angle goes right there. The right angle is not the X and the Y axis. The right angle is off of the X and Y axis. Okay? Mainly off of the Y axis. All right, so it says find all the values, then rationalizes the necessary ones. So this is where we're going to use our SOHCAHTOA. Okay, if you want to remember the X, Y's, and R's, that's fine. We actually won't use those until the very end of class. Okay, we'll come back and reiterate about that. So like I said, I don't normally put my point here. I was just showing you that that's where that ordered pair is. I put it on my sides of my triangle. So over here, I need to find out R. R is representative of the radius of the circle. Okay, that point, 815, is on the circle. So I need to find my hypotenuse. Okay, so when working through this, we need to use Pythagorean theorem. So I'm going to have 8 squared plus 15 squared equals my R squared. So this is going to give me 64 plus 225 is equal to R squared. So that's going to be 289 equals R squared, which means R is equal to 17. Technically, it's plus or minus 17, but we only use the positive because we're talking about the length of a radius. All right, so we're going to go find our sine of our angle theta being right here. So our sine of theta is going to be opposite over hypotenuse. The one that's opposite the angle is 15. Let me do this. So this is opposite over hypotenuse. Okay, so that's going to be 15 over 17 is my hypotenuse. And I just leave it as that, 15 over 17. Now I do the cosine of theta, which is adjacent over hypotenuse. Adjacent means right next to. So our adjacent is the 8 over 17. Now tangent, I can use opposite over adjacent if you want to remember that. Or you could use sine over cosine. It doesn't matter which. In either case, you're going to get 15 over 8. And these are all of thetas. We don't know the angle measure. They didn't give us the angle measure here. The ones up above, they gave us the angle measure. Here, they didn't give us the angle measure, so we just write it as theta. Now, to find your cosecant of theta, your secant of theta, and your cotangent of theta, I do exactly what I did above. I just flip the sine, cosine, and tangent. So this is going to be 17 over 15, 17 over 8, and 8 over 15. Which again, these are values. These on the numbers on the right are values. And theta is your angle measure. They are not the same. Don't tell me that there is a cotangent of 8 over 15. 8 over 15 is your value. It needs to go on the other side of the equal sign. And so that's how you find the 6 trig functions. And again, it says rationalize necessary ones. We don't have any necessary ones to rationalize. They all didn't have a radical. All right, so the one thing I haven't shown you is the Pythagorean identities, okay? Which the identity that we're working with is the sine squared theta plus cosine squared theta equals 1. All right. You could do this problem a couple of different ways. I'm going to show you with the identity, and then I will also show you a different way of doing it. All right. Which might be a little bit easier for you. Okay. All right. So I also need to know which quadrant we're doing this in. Let's say we're going to do this in quadrant 4. Okay. All right. So here I've got, I I can plug in for my sine. Again, this -8 over 11 is the value for sine of theta. So this would be -8 over 11 squared plus cosine squared theta equals 1. So this is going to give me 64 over 121 plus cosine squared theta is equal to, and I'm going to change this to 121 over 121 because I want those denominators to be the same. So now I subtract the 64 over 121. That's going to give me cosine squared theta is equal to, let's see, 47 over 121. And now I need to square root both sides. Okay, so this is going to give me the cosine of theta is equal to plus or minus the square root of 47 over 11. Okay, now the question is, doing it this way, it's kind of challenging because a lot of people forget the plus and minus. And then you've got to go remember, oh, which quadrant am I doing this in? Okay. Well, the quadrant that you're doing this in, that's what's going to tell you which one it is because we're doing quadrant 4. Remember, all students take calculus. Cosine is positive in quadrant 4. So that means that the cosine of theta that we're looking for, actually, let me write it down here, is equal to positive square root of 47 over 11. So you're not going to give both answers. You're just going to give one answer. Now, like I said, there's another way of doing this in which you don't have to use the identity. Don't worry, I'll get you on the identity because we got Pythagorean identities for either test 2 or test 3. I think it's test 2. So I will hit that later. So if you don't use it on test 1, it's not a major deal. Okay. But in this case here, it's telling us, hey, we're going to go for quadrant 4. So draw your triangle here. And you could say, okay, well, this is 8 because it's on the positive x-axis. So this one has to be -11 because it's on the negative x-axis. Again, here's your right angle off of the y-axis. We don't put it next to the y-axis. Then you can go and do it just like what we did in the last problem. We could go find our r using Pythagorean identities or Pythagorean theorem. So we've got 8 squared plus -11 squared equals r squared. Okay. Okay, I gotta go back. Let me get rid of this because I was thinking X and Y and not thinking the way I need to think. Okay, so that's not right, and that's not right, and this is not right. Okay. All right, so here's my theta. Okay. Sine is opposite, so this would be -8 over 11. R is always positive, just in case you're wondering that. All right, so I need to go find my x. So I would have x squared plus -8 squared equals 11 squared. So this is going to be x squared plus 64 equals 121. And so now I need to subtract. So I have x squared equals 47, which means x equals plus or minus the square root of 47. But according to my picture, it's going to be positive because x is going to the right. So it's positive square root of 47. Then after you get that, you can say, oh, well, cosine of theta is equal to adjacent over hypotenuse. And so my adjacent is positive square root of 47 all over 11. And boom, there's your answer. Okay. So you're going to use your SOHCAHTOA to help you out to work it out. Okay. Where you're also working with Pythagorean identity. And you get there a whole lot quicker if you do it this way than having to go through your Pythagorean identity of sine squared plus cosine squared equals 1. So that's why I wanted to show you the alternative way of doing it, because there is a better way. This is the better way, in my opinion. And it saves you from having to do a lot of thinking and whatnot. Okay, so the last little bit here is dealing with solving. Okay, and in this case, it wants you to find the values in quadrant one because we're going from 0 to 90. All right, you can use your hand trick on this. I'm going to show you how to solve. We'll get into solving a whole lot later too. Um, so we'll be doing this again, but they bring it in here, just kind of get you familiar with how to find your angle if you can. So what we're doing, we're actually saying alpha equals the sine inverse of 1 over the square root of 2. Now, don't get too slap happy about this sine inverse stuff. Don't get too fretful about it. I want to know, where is sine 1 over the square root of 2? Well, keep in mind 1 over the square root of 2, if I rationalize, that's the same as square root of 2 over 2. So I want to know, where is sine square root of 2 over 2? Okay, I'm not saying sine of square root of 2 over 2. Square root of 2 over 2, keep in mind this is a value. I am asking, what is theta? Or in this case, what is alpha? Okay, all right. So then we can use our unit circle or we can use our hand trick. So square root of 2 over 2 is actually going to be 45 degrees. And I know I want my answer in degrees because it asked me for it in degrees up in the problem. If it asked for radians, then I would say pi over 4. All right. And I'm spelling out sine so you don't think the square root of 2 over 2 is an angle measure. Okay. All right. Um, Same thing on this next one. I want to know, where is cosine 1/2? So I'm actually looking for the angle measure. Okay. Alpha is equal to what? Okay. That gives me the cosine to be 1/2. Well, that's going to end up being 60 degrees. All right. Like I said, I'm just going based off of the unit circle. I'm trying to find the angle measure that gives me this value. Okay. We cannot do that up here for these problems because they don't give us the values that are on the unit circle. So like for this problem here, that's the reason why we have to leave it as cosine of theta, because I don't know what the angle measure is. It's not one of those nice ones for us. All right. And tangent, again, I'm looking for angle measure. And I want to know, where is it square root of 3? Well, keep in mind that that is going to be sine of alpha over cosine of alpha is square root of 3 over 1. Well, that's square root of 3 over 2 divided by 1/2. So I need to know where sine is square root of 3 over 2 and cosine is 1/2. Well, that angle measure is going to be, again, 60 degrees. Okay. So in this case, they're actually asking you to solve each one of these, okay, to solve for the angle measure. You only do that if they give you the ones based off the unit circle. Do not do it if they give you weird ones. So what do I mean by weird ones? The ones up above, and these here are weird. Those aren't any of the numbers that we really dealt with, okay? All right, so again, draw our picture. Right triangle with sides 2 and 7, so both of those are positive. If they wanted one of them to be negative, they would do it in the order pairs. You just graph it where it is in whichever quadrant. So here I've got 2, and here I've got 7. Okay, the sides are 2 and 7. So I'm going to say 2 squared plus 7 squared equals my r squared. So I got 4 plus 49 equals r squared. So r squared equals 53, which means r equals square root of 53. Again, I'm only using positives because I'm talking distance, okay? All right, so now find all 6 trig functions. So I'm going to do the sine of alpha. I have no way of figuring out what alpha is. It's not one of our famous values. All right, so sine is opposite over hypotenuse. So that's going to be 7 over the square root of 53. Do not rationalize yet, okay? Then I have cosine of theta, which is adjacent over hypotenuse, 2 over the square root of 53. Do not rationalize till you get all 6 of them up here. Then we have tangent of theta, which is opposite over adjacent, so that's going to be 7 over 2. Now I want to go and I want to do my cosecant of theta, my secant of theta, and my cotangent of theta. Now, the reason why I said don't rationalize, because when you do your reciprocal identities, if you had rationalized your sign, you would have to rationalize again for cosecant. So don't get all 6 of them and then go rationalize as needed. So this one is going to be square root of 53 over 7, square root of 53 over 2, and then 2 over 7. So if you do all 6 at first, then all I got to do is rationalize 2 of them. Square root of 53 on the top and the bottom. So this is going to be 7 square root of 53 all over 53. And same thing for cosine. So this is going to be 2 square roots of 53 all over 53. And I will want exact values. Okay, so again, all these values are exactly what we need. And that's it for those 3 lessons. So lots of material in here. If you have any questions, don't hesitate to email me or come by and see me. And I hope you all have a great day.